Okay, so we're recording the session. This is Demystifying Verbal Problems with Hands-on Equations. This is Dr. Henry Borenson, the inventor of the program. If we have any technical issues, please stay tuned. Usually they're resolved very quickly. At the end of the webinar, we will be raffling the Hands-on Equations Verbal Problems book. It contains more than 350 verbal problems from all three levels of hands-on equations. We know from experience that the current school approach to algebra is too abstract and an unmitigated disaster for most students. So that report in 1998 would still be true today. Far too many students are still introduced to algebra at the abstract level. And so we developed the Making Algebra Child's Play workshop in hands-on equations to deal with that issue. Now, before we can discuss word problems, we should take a few minutes to review some basics of hands-on equations. Would you let me know if you are all using hands-on equations or have used it? Just text chat yes if you have used hands-on equations. Okay, so I'm going to give you I'll give you a brief review. So in hands-on equations, the students use pawns and cubes to represent and solve equations. So I'll give you, and this is what the teacher uses in front of the classroom. It has no moving parts. It's just used to illustrate the equation. And the goal is to find the value of the blue pawn. So let's illustrate with one example. This is from lesson 3 of the program. And this is an approach that you can use to have your students as early as the 3rd grade solve equations such as these. So let me share my tabletop here. So we want to set up 4x plus 2 and equals 3x plus 9. So the x's are the blue pawns. So when it says 4 x's, we're going to set up 4 blue pawns. Next, it says plus 2. Well, plus, we know, means to add or put on. 2, we're going to represent that with a cube with the number 2. Okay, so that's 4 x's plus 2. And on the right side, we have 3 x's plus 9. Okay, so this then is the physical representation of this equation. At this point, we can solve it. We use what we call legal moves. If we remove the same value from both sides of the equation, the balance will be maintained. So this would be a legal move, another legal move, another legal move. So notice what's happened. We've taken our equation and simplified it, so now it's much simpler. If this side is a weight of 9 and this is a weight of 2, the pawn must be worth 7. Or if you want, you could also take away 2 value from both sides, and now we get that the answer to this problem is going to be x is equal to 7. Okay, so this is the basic idea for hands-on equations for which I received the patent. Now, once you know that x equals 7, we need to check it. So the way we check it is we reset the original problem one more time. So we have 4 x's plus 2 equal 3 x's plus 9. And if each x is 7, let's see if both sides have the same value. So we have 7, 14, 21, 28, 30, 7, 14, 21, and 9 is 30. Okay, so that's the basic idea behind hands-on equations. So are you all following me, what I just did here? Just text chat yes if you're following. Okay, so the program has 25 lessons. This is the 3rd lesson. This gives you the basic approach that's used. So, according to the agenda for action, problem solving must be the focus of school mathematics. So many students, word problems are very scary, probably because it's abstract. So in order to meet that need, we developed the hands-on equations, Demystifying Verbal Problems Workshop. It's a full-day workshop. So today I'm giving you a very short introduction to that. Here's a young man solving a word problem on the teacher's demonstration scale. So first, I'd like to share with you some problems from the Hands-on Equations Introductory Verbal Problems Workbook. So if you're working with students in grades 3 to 6, this workbook might be sufficient for you. So let's begin with this problem. It says 5 times K's age increased by 2 gives the same result as twice her age increased by 11. How old is K? So this is a problem that I maintain your students can solve in grades 3, 4, and 5 using our approach. So this one I want to illustrate on the interactive application. So let's see. This is problem number 32. Okay, so I want to go to problem 32 here. Give me a second. Okay, so the first thing we do, as we do in algebra, is we represent the unknown. In this case, the unknown is a pawn. So since we want to find K's age, let's write down, let pawn be K's age. Now, we need to set up the problem. So I need your help. How do you want to represent 5 times K's age? Do you want to use a 5 cube and a pawn, or do you want to use 5 pawns? Text chat your response, please. How do you represent 5 times K's age? Her age is a pawn. Would you represent 5 times her age? Would it be a 5 cube with a pawn or 5 pawns? Your suggestion, please. 5 times K's age. Well, this would be K's age 1 time. This would be K's age 2 times. So to represent K's age 5 times, we would use 5 pawns. If you're thinking in terms of algebra, 5x is x plus x plus x plus x 5 times. So we have 5 times K's age increased by 2, so I'm going to put up the cube with the number 2, is the same as twice her age increased by 11. So we want a cube with the number 11. Okay, do we all agree that this is the correct setup? Are we together with this? Okay, so now we can use the concept of a legal move. We can remove 2 blue pawns from each side of the equation. Okay, we can also remove a 2 value from this side. We can remove a 2 value from the 10 cubed, making this an 8. So 8 and 1 is 9. I can just replace these by a 9. So now we have simplified the problem. So we have 3 pawns worth 9. That means that each pawn has a value of 3. Next, we have to write the answer in sentence format. We said that the pawn was K's age. So in sentence format, we would say K's age is 3. Now, the final thing we need to do is the check. I'll show you the check both ways. One way of doing the check is to go back to the original physical setup, and that's how you would do it with younger students. So you have 5 times K's age increased by 2 is the same thing as twice her age increased by 11. So if our answer is correct, both sides will have the same value. So the pawn is 3. I have 3, 6, 9, 12, 15, 17. 3 and 3 is 6, 16, 17. So the check would be 17 is equal 17. And you can also do the check in the original equation, if k's age is 3, 5 times 3 is 15, and 2 is 17, you could also do it that way. Okay, so this then gives you the basic idea on how we solve verbal problems using hands-on equations. So we call it a 5-step approach. We indicate what we want the pawn to represent. We set up a physical or pictorial equation. I'll show you that in a minute. We solve for the unknown. We answer the original problem in a full sentence format, and then we conduct the check. So now, let me show you this problem from the introductory workbook. It says that okay, let me show you that here. Okay, here we go. Okay, so it rained 2 inches on both Monday and Tuesday and 1 inch on Wednesday. It also rained on Thursday. The total amount of rain on these 4 days was 8 inches. How much did it rain on Thursday? So as you see, this is a very, very basic problem. You could even give this problem to first or second grade students. Let's see how we would do it with hands-on equations. So we're going to do this pictorially. So it rained 2 days, 2 inches on both Monday and Tuesday. So over here, I'm going to make a box, and I'm going to write 2, because it rained 2 inches on both of those days, and it rained 1 inch on Wednesday. It also rained on Thursday. We don't know what that is, so I'm going to use a pawn to represent how much it rained there. The total amount of the rain on these 4 days was 8 inches. So over here, I'm going to write 8. Okay, so over here, let pawn B, since it says how much did it rain on Thursday, let pawn B the number of inches it rained on Thursday. We set up on the right solution for the pawn. Well, 2, 4, 6, 7, it looks like the pawn is 1. 2, 4, 6, 7, 1. So now we have to answer in sentence format. So since it said how much did it rain on Thursday, we can now say it rained 1 inch on Thursday. And in order to do the check, you could do the check here. Since we didn't remove anything, we have 8 equals 8. So the Introductory Problems Workbook has this template that the student has to complete. Are we together with what we just did here? So this is problem 9 of 80 problems in the workbook. Okay, here's another one. This one we're going to show on the interactive applications, problem 47. So let's see. Was there an error made? Okay, 1 second. Was there an error made here? 2 inches on both Monday and Tuesday, 1 inch on Wednesday, 2, 4, 6, 7, and 1 is 8. Is 1 correct? Okay, why not? Where's the error here? Because it's 2, 4, 5, and 3 is 8. Okay, sorry about that. So we're going to write the answer as 1 plus 1 plus 1, or 3. 2, 4, 5. Now, the original answer that we selected was 1. So we should have gotten 8 equals 8. If the original answer was 1, we have 2, 4, 5, 6. In that case, we would have had 6 not equal to 8, and then we would have checked the problem further. Okay, so I apologize for messing that problem up. Don't know exactly what happened there. Okay, let's go on. We're now looking at problem 47. Let's do this here, problem 47. Okay, when his uncle asked Matthew to tell him his age, Matthew responded with a puzzle. If you take my age, double it, add 6, and double it again, you get 48. Can you find Matthew's age? So, we know how to begin. Let pawn be Matthew's age. Okay, now I have to set up the problem, so I'm going to need your help. It says, Matthew responded with puzzle. If you take my age, double it, and add 6. So what shall I do, please? It says, double his age and add 6. Please tell me what to do. What shall I put up on the scale? Okay, 2 pawns and a 6. That looks good. That's double his age. And you add 6. And then it says, and double it again. What do we need to do now? What do we need to do now? What do you double? He says, take my age, double it, and add 6. What do I need to add to the scale? Do I need to add 2 pawns? Do I need to add a 6? Do I need to add 2 more pawns and a 6? What else do I need to add to the scale? Well, since this is double his age and you add 6, it looks like we need to do the same thing one more time, okay? So we need to add that one more time. And on the right side, we get 48. So I could put 48 by putting, let me do 48 by doing it this way. Okay. So now we can take away a 6 value from here. Let's do that. A 6 value from here. We just took 12. 12 from 48 is going to be 36, okay? So let me do 36 this way. 10, 20, 36. So now you have 4 pawns worth 36, so I think each one is 9, okay? This guy's supposed to be up here. Answer in sentence format. Matthew is 9 years old. Okay, let's do the check. So we need twice his age increased by 6. And we doubled that, and that's supposed to be the same as 48. So let's get rid of this cube and put 48. Okay, let's see if that works. If the pawn is 9, 4 9s, okay, I'm putting all the pawns together, are 36. 36 and 6 is 42, and 6 is 48. I believe this time we did it correctly. Okay, let me know if this is fine. Okay, good. So let's go on to the next example. Okay, I have one more example from the Introductory Verbal Problems Workbook, and then I want to get to the Verbal Problems book. It says show on the interactive application. Okay, so I'll do that. This is problem 65. 65. The length of a rectangle is 5 units more than its width. So if the width is a pawn and the length is 5 units more than its width, then the length would be a pawn and a 5 cube. If the perimeter of the rectangle is 50, so before we do anything with the rectangle, let's just mark it. This is a pawn, and this side here is a pawn and a 5. Excuse me, and we know the perimeter is 50. So now I would like your suggestion. What would you like to do here? How would you like to set this up on the scale? By definition, the perimeter is the sum of all 4 sides. Okay, one approach is to actually lay out all 4 sides, which would be, if you laid out all 4 sides, you have a pawn and a 5 here, and also here, a 1 and 1, so you have a total of 4 pawns and 2 5 cubes. Another approach is to use the semi-perimeter. In other words, if this is the width and this is the length, we now have the semi-perimeter. If the whole perimeter is 50, what's the semi-perimeter? How much is one length and one width? It's going to be 25. So why don't we do that? So now this equation is a little simpler, right? So we're solving it by using the semi-perimeter. And now we can easily solve it because we don't have to do anything else. Notice we have a 5 cube and a 5 cube. Here we have 2 10s and here we have 2 pawns. So that means that each pawn is 10. Okay, see if you could follow me. Without doing any additional work, each pawn must be 10. Do you all agree? Each pawn must be 10. So how long is each side? So since the pawn is 10, we have that the width is 10 and the length, do I have length spelled right? Length, I'm having trouble. Length is 15. Okay, in order to do the check, if this is a 10 and this is a 15, we're going to see that the perimeter is going to be 50. So the check is, I'll just write 50 equals 50, but the perimeter is 50. Okay, so right now what I want to do is go on. Okay, before I do that, can I have some brief feedback? What do you think about the approach you're seeing here? Okay, a little feedback. What are your thoughts about what you're seeing? Good, okay. It's not intuitive for you, okay. I need practice, okay, good. Okay, so it will be a way to get hands-on on the problems. So now let me show you some example from the Hands-on Equations Verbal Problems book. So this time I'm going to do it on the screen. So now we're doing more advanced problems. So these would be middle school problems or high school. The sum of 3 consecutive numbers is the same as twice the value of the last number. Find the numbers. Okay, this is easily a problem you could find in any algebra book. So the first question is, what do we mean by consecutive numbers? For example, if the first number is 10, consecutive numbers, 3 of them would be 10, 11, 12. So let's say the first number is a pawn. What would be the next consecutive number after that? How would you represent it? How would you represent the next consecutive number after a pawn? Would it be 2 pawns? Or would it be a pawn and a 1 cube? You want it to be a value of 1 higher. Would it be 2 pawns or a pawn and a 1 cube? It's going to be a pawn with a 1 cube. A pawn, for example, if the pawn is 10, all of this is 11. If you use 2 pawns, all of a sudden this would be 20. Susie, do you see that the second number has to be a pawn and a 1 if it's going to be 1 larger? Okay, what would the next number be? It has to be 1 larger than the last one. So far we have pawn and 1. The next one would be what? A pawn and a 2. Okay, now I want you to notice something. Once you have this set up, I want you to notice how intuitive, that's the word you suggested, the equation or the setup is going to be. It says the sum of 3 consecutive numbers. Well, you all know what sum means. Sum means put together. So therefore, I need to begin with the pawn. That's the first number. Since it says the sum, I need to do what? I need to add the second number. So let me add the second number. And I need to add the third number. So I'm going to stop right here and see if you're with me. Do you agree that this is the sum of the first 3 numbers? Right? Sum means you're combining them. It's very straightforward. I think, anyway. Is going to be the same. So now I have to go to the other side of the balance scale. The same as twice the value of the last number. I need to know what to do. On the right side, I need to place twice the value of the last number. So what shall I do? The last number we see here is a pawn and a 2. So what do I need to do in order to represent twice the value of the last number? I need to place a pawn and a 2, but I need to do that a second time. So would you check that out, please? This is now twice the value of the last number. Everybody agree? Lauren, Susie, Diane? Okay. Now, in a minute, I'll show you what this equation looks like abstractly. It looks like a whole different ballgame because you're going to have parentheses and so on. But notice how elementary. Well, now to solve it, well, let's do some legal moves. Let's take away these 2 pawns from this side. And let me take off these 2 pawns from this side. Now I could take away 2 value from this side and a 2 value from this side. And now I don't have to do anything else. I see that the pawn is equal to 1. 1 plus 1 is 2. So therefore we now have that the pawn is equal to 1. And therefore we're ready to write our answer. What are the 3 numbers, please? If the pawn is 1, we have represented the 3 numbers. So what are they going to be? It's going to be 1, 2, 3. Because 1 plus 1 is 2. So the 3 numbers are 1. The 3 numbers are 1, 2, and 3. And let's do the check to see if it works. This time we're going to do the check in the original problem. The sum of 3 consecutive numbers, 1 and 2 is 3 and 3 is 6, is supposed to be equal to twice the last number. The last number we said was 3. And the answer is yes. 6 is equal to twice 3. So do you see how we solve this problem? Now, if we try to do this with algebra, and you call the number x, let's see what this would look like. Okay, let me see if I can do this. It would be x plus x plus 1 plus x plus 2 equal twice the last number, which is x plus 2. Okay, it's not that bad, but it's certainly not as simple as what we had, right? This looks more abstract, more complicated. You have to know what to do with the 2 in the parentheses. Okay, let's go on to this problem. Again, this is for middle school or high school students. 10 years from now, Tommy will be 4 years older than twice his present age. How old is Tommy now? So I need your help. What would you like the pawn to represent? What would you like the pawn to represent, please? "10 years from now, he's going to be 4 years older than twice his present age. How old is Tommy now?" So the answer to that question, not always, but very often, we get the representation from the question. Since the question is, how old is Tommy now? Let pawn be Tommy's age now, okay? Now, how do we represent his age 10 years from now? Can I have a suggestion? If Tommy is a pawn represented by a pawn now, how would you represent his age 10 years from now? In 10 years, Tommy will be a pawn and a 10 cube. Are we in agreement with that? Good. Good. So now we have a representation for Tommy's age now, his representation in 10 years. So I think now we're ready to do the problem. Because we're told 10 years from now, that's this. So let's see, 10 years from now, Tommy will be, so I need the other side of the scale, 4 years older than twice his present age. So twice his present age would be what? 4 years older than twice his present age. This is his present age. This is twice his present age. This is 4 years older. So please check this out. These pieces here represent what you have up here. Okay. Why the 1 cube? The problem says, and 10 years from now, Tommy will be, okay, so this is another error. This should be 10. Thank you. Okay, let's see if we have it this time. 10 years from now, that's a pawn and a 10. There'll be twice his present age. Are we okay now? Okay, good. So now we're ready to solve the problem. We could use a legal move here and a legal move here. And now we see that this must be 6 because 6 and 4 is 10. So therefore we now have that what? We now have that the pawn is equal to 6. And now we need to write the answer in sentence format. So Tommy is now 6 years old. Let's do the check in the original problem to see if it works. 10 years from now, so that would be 6 plus 10, and that equals 16. 10 years from now, Tommy will be 4 years older than twice his present age. Twice his present age is going to be 12. 4 years older would be 12 plus 4, which is 16. So the answer does work out. Okay, so if you're teaching algebra or have taught algebra, you know that some of these problems are difficult for students, and this is an approach where they can concretize and visualize the problem. Were you all able to follow what I did here? Okay, good. Okay, we'll do one more. We'll finish the setup with this problem. Now, this problem says 2/3 of a number. Wow. How in the world are we going to do that? 2/3 of a number increased by 4. How do we represent that with our pawns and cubes? Well, if we had the ability to break the pawn into 3 equal parts, we might be able to do it, but we don't know how to do that. We have to use a little ingenuity. Let the number be, anybody know how you want to represent the number so that we can easily find 2/3 of it? What do you think the number will be to enable us to easily take 2/3 of it? What representation shall we use for the number so that we can easily take 2/3 of it? We don't want to use a pawn because we have to break it up into 3 equal parts. That's not so easy to do. Let the number be. Okay, one of you guys must have it. How do you want to represent the number? After I show you, you'll say, oh no, why didn't I get it? No, a fraction piece. Okay, that's good, but you could do that too, but that's another program. Okay, very good, Susie. Using the blue blocks, you could do it very nicely. Okay, after I show you, you guys are going to wonder why you didn't think of it. Let the number be 3 pawns. Why does that help? Because once the number is 3 pawns, then 2/3 of the number is what? What's going to be 2/3 of 3 pawns? 2/3 of 3 pawns is going to be what? 2/3 of 3 pawns is going to be 2 pawns. Okay, so now let's see if we can do the problem. So it says 2/3 of a number. So here we have, let me bring it down a little further. We have 2/3 of a number increased by 4 is going to be the same as 1/3 of a number. I didn't write it down, but 1/3 would be 1 pawn increased by 8. So look at that to see if that makes sense to you. I guess I can write it down here. One-third of the number is a pawn. Okay, so here we have 2/3 of a number increased by 4 is the same as 1/3 increased by 8. So now let's get rid of this pawn, get rid of this pawn, and now we see that the pawn is equal to 4. Okay, so we have that what? Pawn is equal to 4. So that means that so what are the numbers? I mean, what is the number then? Well, the number is represented by 3 pawns. So pawn is 4, and the number is 12. Okay, then if the pawn is 4, the number is 3 pawns, the number is 12. Let's just double check it to see if it works. 2/3 of 12, that's 8. That's supposed to be 1/3 of 12, which is 4, increased by 4, and that does work. Okay, I know I did this a little fast here with the check. 2/3 of 12 is 8, increased by 4, that's going to be 12. And on the other side, let me do this again. is the same as 1/3 of the number, which is 4, increased by 8, which is also 12. Okay, so it does work. Okay, very good. So I'd like to thank you for your participation in this webinar. I trust you see that this approach can be very valuable for students as an introduction to word problems, and then they can easily make the transition to the pictorial notation and the abstract notation. Available are class sets of materials of hands-on equations. We have the Introductory Verbal Problems Workbook, and we have the Verbal Problems book, which I mentioned to you. We have the interactive application. Thank you, Diana. And we have staff development workshops available, making algebra child's play, demystifying verbal problems, developing fraction sense. So thank you for participating in this webinar. If you're not familiar with our Facebook page, Borenson.com, there are literally, I don't know, hundreds of videos, certainly more than 100 videos there of children learning, showing different mathematical problems. Okay, Susie, you have not done much word problems, is that correct? Right, okay, good. Instagram, I don't know how to use Instagram. I need someone to help me. We need to use Instagram to market. We have not used Instagram. I'm ages behind on that. My goodness. Okay, we have a raffle. We expected 12 people. We had good, about a third of you here today. I selected a number from 1 to 12. Would you select a number from 1 to 12? Let's see who's the winner of the raffle. Okay, I think we have one more person, right? Diane, Susie, Lauren. Instagram is easier than Facebook. Maybe Diane can give me some coaching here. Okay, did everyone enter a number? I thought we had another person here. Nicole, are you still there? Okay, so I see 3 numbers. Let's see who the winner is. Let's reveal the winner. Okay, Nicole, do you enter a number between 1 and 12 if you were with us the whole webinar? Okay, Nicole entered the number 1. The number is 3. Nicole, you're the winner. Congratulations to you. Okay, you're the winner of the Verbal Problems Workbook. This one that we just had here. Okay, so my office will contact you, or you could contact us at info@borenson.com. Okay. All right, so thank you all for your participation at this webinar. Again, I apologize that I had some trouble in the beginning. I was afraid that I would not be able to get in, and I finally did. Thank you so much. We'll be sending you a recording if it came out. So have a wonderful day. Thank you.